all of the systems that are put together in order to support autonomy. The one thing that has not worked is antenna, and antenna is key. And it's the way in which we design our antennas that enable that accuracy versus the patch antennas which are available on the market. At Helix, we have a dedicated team of PhD, principal scientists, RF and mechanical engineers, a whole team of manufacturing engineers, a great commercial team, and support infrastructure in place. Dr. Oliver Leestein has been working on this technology since 1990, in the early stages where it was, antenna design, and then ultimately, more recently, as we are doing at Helix, in miniaturizing the helical antenna design. The SAE international standard requires that there should be no more than 10 centimetre for 95% of the time in lateral error. 10 centimetres is key.
With our antenna technology, because it's a dielectrics core, it does mean that we've got a really much tighter phase center, which basically means that as compared to a patch antenna, you have your phase center is as big as basically the skin effect of the vehicle, which basically means a patch antenna, in layman's terms, has a really terrible positional error because the positional error is dependent upon the size of the vehicle. You go to a helical antenna, then the positional error is effectively maintained within the antenna itself, so you don't have the vehicle to worry about. Then you have the ceramic core, which basically improves that positional error even further by holding on to that energy within that antenna. Now what we're talking about is that when you put arrays of antennas together, then what you've got is you've got each of the phase centers of each of those antennas, and they're actually pulling together the accuracy and making that even more accurate and making it even tighter. But then what happens is that when you get an interference coming in from one direction, you can reject that interference but maintain the positional awareness from the other directions.
We joined the CAM Scale Up UK programme because it actually aligns with our vision for the future, and it's actually enabled us to accelerate what we were doing on our own roadmap and giving us access to resources, to industry experts and a network of industry leaders, which we would not have been able to do otherwise. It's absolutely crucial to be able to test our technologies in an environment which is as realistic as possible to what the real world activities are. Hariba Mirror's anechoic chamber provides a controlled environment for us to simulate interference and jamming signals and allows us to take EMC measurements of the antennas. UTAC Millbrook provides a surveyed, repeatable environment with a real-time kinematic RTK system, which we can utilize to compare positional measurements to validate accuracy. Smart Mobility Living Lab London provides a test vehicle, a Nissan EV100, which has a Novotel Truth system on board and access to a surveyed, datum-referenced open road environment.
The London City area provides a really great opportunity for testing purposes. We've got the urban jungle environment, we have really big high-rise, tall, reinforced concrete steel structures which basically provide very good multipath reflections, which typical antennas in navigation systems really do struggle with. 5G interference is a big issue within the urban environment, and here is a great location with TV towers and lots of 5G transmitters to be able to actually simulate and test this in a proper real working environment. By utilising our arrays, what we're going to show is that basically we can reduce those errors down, we can improve the accuracy of the overall navigation system.
This programme has enabled us to start developing and collaborating with manufacturers of receivers. We've got collaborations with like Sony, Honeywell, and others. So these are significant. And the tests that we can do enable us to validate a lot of these processes. It enables us to be able to optimize the best solution for autonomy in the future.
The big issue that is stopping connected and automated vehicles from being out in the public roads now is the issue around maintaining the position. It's fine, like having a corridor along a motorway, that's absolutely fine. But the bigger issue is being able to operate within the urban environment. If we achieve this, this is going to solve one of the biggest problems and hopefully open up the market to actually progress connected vehicles and automated vehicles.
We're at the forefront of innovation. We are addressing a real world problem, and to be able to have a solution is extremely exciting.